So let's talk about doing an assignment. This is similar to that first week when I had you use Blockly to draw hexes. I want you to draw hexes again. In this case, I want you to draw this particular sheet, which is 11 vertical by 13 horizontal. And I want you to do it in C++. So I'm actually going to start it off for you. You can download the tarball, get it into the location where you're able to extract it. I'll have to do that. All right. There it is. You can follow this command here that I haven't read. tar xf xv. It'll show you that it extracted 3 files. So it didn't put them in it didn't create what assignment is this? It didn't create like an A10, so you'd want to do that and cd into A10 before extracting the archive, since it doesn't create a directory for you. There are 3 files here. Let's see. Probably the one that would be most interesting / useful will be Hexagon.h. And you can ignore lines 1, 2, and 7. We'll talk about those later in the semester. But what's of interest are the 4 functions. These are, again, function prototypes or function declarations. If you include a copy of this header file in your code, you will then be able to use these 4 functions. And no mystery as to what they are. Move forward, move backward. They default to a 1/4 inch. We'll talk about that more in a moment. You shouldn't need to touch that. Turn right by and turn left by, where you provide a number in degrees. Rather than just simply staring at that, let me go ahead and look at that. There are 2 more. The second is draw hexes, which is where you would actually, if memory serves. Yes, so this is where I began writing a little bit of code. We'll look at this in a moment, but you'll note that first of all, I didn't include IOStream, and I didn't say using namespace standard, because we're not using cin or cout or endline or any of the other stuff associated with input and output. And the using namespace standard was to allow us to use things like cin and cout without preceding it with the cumbersome std : to avoid that extra syntax sugar that we have to put here. Since we're not using the input and output facilities, we do not need to include that file. The only file we need to include is the one that you see at the top of the screen. Here's my main function. And here I have a for loop. I am creating and initializing at the same time a variable I, setting it to 0. As long as it's less than 6, I want to do something, and then at the end of each iteration through the loop, I want to add 1 to I. As you become fluent in programming, the pattern of starting at 0 and looping or iterating less than a number means you're going to loop that many times. So I can just glance at this, having seen this a million times before, things like this, and go, okay, this is going to loop 6 times. Starts at 0, less than your destination. Right, so the numbers are 0, 1, 2, 3, 4, 5 that it does. What am I doing 6 times? Moving forward and then turning right by 60 degrees. So there you can see what you do to actually use the functions. There is a third file here, which is Hexagon Dot Cpp. Let me zoom in here for just a moment. You're certainly welcome to look at it, but there's no need to. And what this code contains is it contains code that I wrote that actually does the behind-the-scenes drawing. right? It's all the code. Let's see if we can find it here. All the code behind these four functions: move forward and move backward and turn by. And you see some trigonometry in there. Things that you know and love, like pi. So you're certainly welcome to look at it. For this assignment, definitely do not modify it if, in general, you're just kind of the curious type and want to play around with the file outside of this assignment. By all means, tear it to pieces. So that explains all those files. This, as I read through the directions, it shows me a G++ line here. I'm just going to copy and paste that. So note that I have to put not only the file where I am writing my code, which again is draw hexes, but I also have to put the file that contains all that stuff under the hood for those four functions. Basically, the source code of those four functions has to be on this line as well. Note, very importantly, the header file is not on this line. If you put the header file on this line, you're going to run into problems. Okay, so don't do that. Why? Because you pound included the header. That's part of the reason you pound included the header file, right? So you pound include header files when you need them. You never, ever, ever put them on a line where you're compiling. And then the -O option, we know if you leave that off, it'll be a.out. If I leave it on, my running program will be called drawsheet. Now, if I just run drawsheet, I get HTML, okay? And it's spit to the screen, and that isn't very useful to me. What I need to do is I need this output to go to an HTML file, and then I will go and, in my web browser, open up that HTML file. So the way to do that is I run it, and then I do this little trick where I use a greater than sign, and I give it a name. Let me see what name I gave it in the write-up. Output.html is what I called it in the write-up here. Output.html. Call it anything you want. Make sure it ends in .html. Now nothing goes to the screen because all of that output that we see here went to the file. We can look at the file just to confirm, and there's all the exact same HTML code. Now Vim is nicely syntax coloring it for us. So now we need to open that up. So I go to a web browser, and if you know how to type it in directly, you can type it in directly. If you don't, you can go to Open File, and then you just have to hunt for that file. And that file's right here, and voila, there's my hexagon. I'll zoom in here a little bit. So let's look at what that code did real quick. I don't think it is draw Hexes.cpp. Loop 6 times, move forward, turn right by 60. I have a little picture here that I drew before class. You're starting right here, facing to the right. It moves forward, turns right by 60, so then it's here, and then it does that 5 more times until I end up exactly where I ended. So when I'm done running this program, my cursor or pointer or whatever you want to call it is in the upper left-hand corner here, moving to the right. An observation that I probably made with the Blockly, I don't know if I made it in class, I certainly made it to some individuals, is what if my pointer wasn't here when I started? What if my pointer was, what if my pointer had happened to be over here when I started? Now it isn't, the answer isn't complicated. The answer is, well, if the pointer was over here when I started, then I would have drawn a hex over here. Yes? All right. So using that not huge insight, the idea is you want to get your pointer, after you finish drawing the first hex, you want to get your pointer right here so that when it draws the second hex, it draws it immediately below. If you're doing it that way, I suppose you could be drawing zigzag going across, whatever catches your fancy. So let's try that. Actually, let me delay that. We'll talk about that in about 15 seconds. We started talking about functions. I want to take advantage of this code I just wrote and put it in a function. The function doesn't return anything. I have to give it a clever name. I kind of worked with pencil and paper half the night and came up with that function name. And now I just need to stick what I want in that function. And what I want is I want lines 10 through 14 in there. So I'll say colon 10 comma 14d for delete. And then I'll come up to this upper curly brace and type P for put. Now, whenever I want to draw hex, I just say hex. All right. Let me prove that that works real quick. I rerun my compile line. I rerun the program, and then when I refresh the screen, there's nothing different to see because it drew the exact same thing. So it definitely works. But let me come back in here. All right. So I've created a little function there. Now here I can continue to write code. And what I want to do is I want to get my, where's my drawing? I want to get my pointer, which is facing to the right. I need to get it down here, facing to the right. And so I suppose I could go 1, 2, 3, 4. It's probably shorter to go this way, but it doesn't matter. I'm going to go 1, 2, 3, 4. I'm going to create a loop and go this way 4 times, which won't get me all the way there. It'll get me most of the way there to where I need to be. I'm actually going to borrow lines 6 through 10 again. 6 through 10, I'm going to yank. I'll say P for put, and then if I only want to do it 4 times, I do 4. That gets me pretty darn close. However, what it does is it gets my pointer here. Facing that way, and I need it to be facing to the right if I'm going to call that hex function again. So now, after we do that loop then, we just need to rotate it back to the right, what is that, 120 degrees? So I'll say turn right by 120. I want to do a little test. I want to see that I did turn the right way. So after I have gotten down there, I'm going to move forward, and I'm going to put a number in here. I'm going to move forward by an entire inch. So it should draw this glaring straight line in the direction I'm facing. It's a good way to test to see if you're pointing the right way. So I quit out of that. Again, this would go a little bit faster if you had 2 terminal windows open, one for editing, one for compiling and running. I'll rerun it. Now I just have to come back to my web browser and refresh. So yes, indeed, I am right here facing that way, and I drew that line going that direction. Okay, so I'm going to go back into my code. I don't need that anymore. Now I'm ready to draw the next hex. So let's draw the next hex. I just say hex. Let's see if that works. Compile, run, refresh. There we go. All right. And then finally, I want to keep taking advantage of my functions. So maybe what I'm going to do is put lines 16 through 21 into its own function. And what I'll call this is move down to next position. And then what did I say? I said, now the line numbers have changed, 19 through 24. 19 through 24, delete, put. Now between these two, I just call the move down to next position function. So compiling it, running it, refresh, still works. And then the final piece I can do here is make the observation that I can really do these 2 steps over and over again. Let's put those in a loop. For anti equals 0, I is less than 11, plus plus I. Let's draw a hex and then move down to the next position. Run it, refresh, and there are my hexes. Okay. Now we could actually take all of this and throw this entire thing into a function called draw vertical row or something like that. So you see how this builds? So that's what I want you to do. And I want you to be getting together with other folks and working together on it if you're inclined to. I'd certainly very much encourage that. Any questions? Yes? I'm going to try to get it to Blackboard in the next 5 minutes or so. Yeah. Absolutely. If you got your Blockly code, then I think that's a fantastic idea to use that. Yeah. Other questions? Yes.
Just curious. You know how when we started this, we were at that one point before we created all those hexagons. Is there a way to go back straight to that point, or do you have to?
You have to do the Etch-a-Sketch, trace lines back to it. Yeah. Say that again? No, not unless you have some reason to want to. Yeah. I'd like you not to have a tail. You should be able to do this one without a tail. Anything else? Okay, I think this question's worded. This is a couple days ago, and it's worded a bit awkwardly for me to read it. But I think this is just asking about creating functions, and I believe that through Wednesday and what I've just shown today, that gives you some answer to that question. If not, let me know, and we'll hit it on Monday. And then I'll definitely get you some solutions to the loops assignment posted. All right. So I'll cut you loose. I'm going to stop the recording, get it all posted to Blackboard real quick so that you can use the code I wrote as a reference if you like.